Right, greetings all, hope this finds you well as always. It's now time for the latest update from the machine shop. First up, as you can see from the mess on the Mustana, there's been more rod brasses being machined, and the first of them is there. Sorry, that's actually 1825, so that, apologies, it isn't quite finished. That's the last of the two big end brasses of 76079. They're the last of the rod brasses off that engine that need remetalling, so they've been remetalled, bored out. The only difference with the big ends as opposed to the rod brushes is there's a radius on the inside end there that's had to be added as well. So there's one of them there. The last job these need is, if you look, you can see, if it stops rolling, there we go. You can see where the oil pad has been filled with white metal during the recasting process. So the last job is to machine that white metal out, refit the keys, which are sat there ready to go, and then that can be pressed back into the rods. Incidentally, on the subject of the white metal, the swarf, the material we use, we will recycle. We can recycle the white metal that's cast into the bushes. So we recover the swarf, segregate it from all the other materials, all the other waste streams, and then we'll melt that down and reuse it. So a little bit of recycling for you. Anyway, okay, moving swiftly on. Dan Middleton's busily at it again. Get more valve rings coming out the system. Another little pile of goodies there ready to go, mostly for 80136. Yeah, they're all for 80136 by the look of it, so he's been busily on with that. Craig, my volunteer, has been back in, and he's been making a start on new bushes for 76079, so we can see one of his new bushes there, ready to go. And so that just needs grease holes adding, and then that can be pressed in. There's quite a few bushes to do on that. That combination lever needs 3, then the other combination lever needs 2, and there's a couple of others as well, so there's quite a few to do. So, okay, Brian, my other regular volunteer, has been in, and he's been busily rattling out gauge frame fittings. These are replacements for ones that were condemned by the boiler inspector. He's nearly got that job finished. There's just a little bit of finishing work to do on these ones near the front, and that job's done. It's a smashing job he's done there. He's really top hole with this small fittings work like this. And I'm busily making a mess on the Fritz milling machine, where I'm busily making some bits for the weighing gear. What we need is strips, which look roughly like these, as to this drawing supplied by young Mr. Jeffrey, and we're having to mill them out of the EN16 because we don't have any EN16 flat. What I'm actually starting with is EN16 bar and basically milling it down flat, which on one hand is incredibly wasteful. On the other hand, if you can't get the material, and I'll be honest, at the moment we are struggling to get some grades of steel and certainly some sections of steel, then yeah, you have to make do with what you've got. And at the moment, we've got plenty around EN16 on the shelf that we can replace easily. So, yeah, I'm making a lot of swarf. Incidentally, that swarf is supposed to be blue. Do not adjust your set. This is not an optical delusion. It's perfectly normal. I have a nasty habit when using carbide tooling like this face mill of running dry with no coolant. As a result, the entire heat from the cutting operation goes into the swarf, into the chip as it's known. And due to the swarf then oxidising the air, it goes this beautiful blue colour, which I quite like actually. It's known as, in the trade, it's known as overtime blue, in case you're wondering. You also get piecework purple sometimes, so there you go. Anyway, leading on from Brian and his gauge frames, I had a question posed to me last week, which is, what are these gauge frames of which you speak? And to show what we're dealing with, I've nipped this out the stores, and it's one of the gauge frame assemblies off 75029. Now, first of all, it's 90 degrees out. It should be vertical. Unfortunately, my vise isn't vertical, it's horizontal, so it should be like that. It's actually like that, okay. Right, what we have here is these two pads here and here bolt on to the boiler backhead. And if we read one of these assemblies off, you will see there's a port through that casting, through which communicates with the steam or water space in the boiler, okay? And the same is true of that end. So we've got a passageway going all the way through to here. Normally, there'll be a glass tube mounted into these two. There's a few bits missing off this, so I do apologise. The gland nuts and a few other odds and sods are missing. But there will be a glass tube sitting from there to there, and that tube, because water's a liquid and all the rest of it, will show the level of the liquid within this region, which is, this is usually this also is directly related to the position of the firebox crown as well, so it tells you what depth of water there is over the firebox crown, okay? So there should be a glass tube in there. Now, one of these bungs we're busily making, there are various of these on the gauge frames, and they're simply for access, for maintenance, repairs and whatnot. There should be one in that hole there for a start. First of all, if you need to fit a new glass, as we do every 28 days or whenever any breaks, we need to be able to get in to sort of get the old one out and get the new one in. So that's what that port there's for. You can slide the glass in or out, fit a new one, and then one of the bungs, one of these little beauties, which Brian's been busily knocking out, will then go into that hole, okay? The bungs on the front, like this little one here, they are for another piece of maintenance, which is to verify that the passage, which goes from here all the way through to here, and through into the water space, is actually clear. There should be a isolating valve spindle in this hole here. This is the problem with steam engines. As soon as any bits of them sit around for a while, parts get cannibalised to go on something else. There should be a spindle through there, which is a quarter turn on-off valve. And the object of this port here, which we've removed the bung from, is so you can rod through with a test rod to verify that that port there and this cock and all the body through there and on into the water space is clear. So there's no danger of it getting blocked by anything, okay? So the idea is, that's the same on that side, that's the same on there, okay? Again, you can rod all the way through these cocks. The idea of these is so you can isolate the gauge frame if the glass shatters, or if the locomotive's been stable for a long time, for instance. And then you've actually got a third cock here, which is actually still intact. You can see the spindle in it there. They should be identical to that in there and there. Now this is so that you can drain the glass down. If you just close those there, that glass would still be full of water. So if you open that, you can drain it down. You can also, by opening that valve there, while these two valves are here, you will also vent steam and water through these passages here and here, and so you can verify the whole assembly is free and clear. So when I talk about these gauge frame fittings, that's what we're talking about. It's the assembly that goes onto the back of the locomotive boiler that tells us what the water level is in the boiler, and what Brian's busily rattling out are various of these small bungs which go into them to seal up the various ports which are there for the various bits of maintenance that need to be performed on them, okay? Right, moving on, a second question. Piston packings, how do they work? Right, we're looking specifically at piston packings off Repton. I know LMS and BR standard piston packings are subtly different, and we will come to them in due course, okay? Right, what you have to remember is the piston in the cylinder on a railway locomotive is a double-acting piston. That is, steam is being admitted to either side of the piston, as opposed to a single-acting piston, where steam will simply propel the piston along the cylinder one way. In a double-acting, it will be worked backwards and forwards by steam being admitted to either side of the piston. Now, on one side of the piston, that's dead easy, because there's no opening in the cylinder block, apart from the drain cock. It's nothing, it's just a sealed volume with one wall's the piston. The only problem is, on the other side of the piston, there's the piston shaft, which goes outside of the cylinder block to the crosshead. And so what you need at the far end of the cylinder block in the rear cover is a steam-tight seal around that piston shaft, because otherwise every time you emit steam to that side of the piston, it will just simply roar straight out of that great hole in the back of the cylinder and won't be doing any useful work. And that's where the piston packings come in. Once upon a time, when the world was quite a bit flatter and Mr. Stevenson was just about thinking there might be something in these colliery pumping engines, you know, cylinders would have been simply sealed with rope or tallow or anything like that. But as they got higher pressure, they started to use these metallic packings. And so this is the idea the Southern Railway came up with. Now, each of these sets of packings, you'll see the 3 segments in that there, each of these sets of packings sits into one of these cups. Now, these cups then sit onto the piston rod. The piston rod is coming up through the middle here, okay? So the idea is These cups act to retain the piston packings, and there'll be 3 of them, 1, 2, 3. And so each with a set of packings within them. And the face of each cup will sit up against the face of the piston packing. This will be machined completely smooth. And then there's a large spring that goes onto that spigot there, which applies pressure onto the whole lot. And so pushes them all face to face together. So each piston packing is sealed to the bottom of the cup, which holds the next one, and so on and so forth, all the way up to the back cover. And the back cover will sit straight onto a piston packing. Now, to seal them onto the piston rod, what happens is this centre hole here is we gap them. We insert a bit of wire here into each of the gaps to open those up, and then we'll bore that, with those gaps opened up, we'll bore that hole there so it's a sliding fit on the piston rod. We then put what we call a garter spring, it's like this endless spring, around the outer edge of the piston packing in that groove there. And what that does is that closes the piston packing down onto the rod. So it will seal on that, but because it's a nice smooth sliding fit and it's bronze on steel, it will run lovely and smooth with a little bit of lubrication. But then because it's then sealed on that face onto another cup with another packing, with another cup with another packing onto the back cover, it's steam tight. So that's the roller piston packing. So to provide that steam tight seal around the piston rod to ensure that the steam, when it's emitted to the rear of the piston, is actually doing useful work rather than just roaring out. Now, these are Southern Railway packings. BR packings and standard packings are BR and LMS packings are slightly different. We'll cover them in due course when we actually get something to machine. They're a slightly different design, basically, but they do exactly the same job. Okay, so I hope that clears up the questions a couple of you had. So anyway, folks, that's where we're up to, and that's where we're at. We're pretty busy at the moment. We're starting to think about putting stuff back into Steam. Eric's in Steam on Monday. And so, yeah, there's the inevitable bits we're finding that we needed yesterday to do various things. So now, folks, I hope you found it educational, informative as always. Now, take care, and I'll see you around.